Okay, I think this is the first time we're using this mic today, so like if I can get a show of thumbs up if everybody can hear me. All right, perfect. Okay, so first of all, after you already said, we'll hopefully get the most boring part of the conversation or the talk out first. That's my name, and if you've been to our booth, you know that this is like our adorable little logo. His name is Constantine. He will make quite a few appearances. First and foremost, I am, like they said, a Kraken engineer working for Octopus Energy or Kraken Technologies. We build Kraken, which is like a big software platform for green energy companies. If you want to talk way more about that, definitely come and see us at the booth. And then just like trivia facts, like I'm also a yoga teacher. You might ask yourself, like, why the heck would he mention that? And it's for no relevance at all, other than it took me a very long time to do, so I like to brag about it as often as I can. So if you are interested in yoga, I know that we have like these open spaces, so like if anybody wants to like do an impromptu yoga session tomorrow, maybe we can organize that. We'll see. But yeah, again, come and talk to me about that later. That will be the end of the yoga portion of the talk. So, okay, the talk is Lint All the Things. I guess we should first start off with like, what's a linter? And this is, I think I got this from Wikipedia. So, analyzes code to flag errors, bugs, stylistic errors, and suspicious constructs. As oftentimes I find stuff on Wikipedia, it's pretty wordy and may or may not actually be true. So we'll start to like kind of break that down into something that makes a little bit more sense for us. But it does do, I mean, this like does make sense, and it does do all these things, but there's a little more nuance involved. So I like to think of it as like three things. A linter can be a critic, so it can complain about your code. Like when you do something you probably knew you shouldn't do, maybe the linter can say like, hey, by the way, that's not good, don't do that. A lot of the way we use linters as well at Octopus and Kraken is as a teacher. So sometimes people can do something in their code and you know that they can do it in a better way. So not only can the linter be a critic, but it can also say, hey, by the way, I think you were trying to do something like this. Maybe you should do this instead. So for junior developers, that being like very helpful in like them learning best practices and stuff. And then this last one, since you can probably already tell from my accent, I am from the States, and I used to have the word janitor here, which I talked to my UK colleagues, and I realized that that word is probably not going to make a whole lot of sense. So I changed it today to caretaker, which is like someone to come up and clean up behind you. So we also do that as like linters as well. Like maybe you kind of want to make a little bit of a mess, and then you want somebody to come back and clean it up for you. It's really great to use computers for that. So linter can kind of be a caretaker as well. So why? Okay, so now we know sort of like what a linter is for and what kind of things it can do for us, but like why do we actually use them? And for me, the first and foremost reason is because we're humans and humans make mistakes. As you all know, if you've written any line of code, there's a pretty good chance you've written at least one bug. Or often we write bugs. That just happens because software is very complicated. And because the discipline itself is actually pretty young in comparison to like other disciplines. So we're all still kind of figuring this out together. But since we're humans, we make a lot of mistakes. Another way that we can use, like a reason to use linters, is we can codify these best practices. So for like some of the people on our team that have been developing software for years and years and years, you kind of get the sense of like what's a good thing to do or what's not a good thing to do. And that typically comes from like doing the wrong thing a bunch of different times. So like me specifically, I've done the wrong thing a whole bunch of times. That's why I have like a set of best practices. And those come from mostly just doing it wrong. But instead of just like putting that in a documentation or something like that, we can codify those using these linters and start to, again, like taking a linter as like a teacher, we can help to like junior developers realize that these best practices exist and how to use them. Another reason is consistency. So I always tell people on my team, if I open up a file and I can point to the person that wrote that code, that's like not a good thing. Because you want all your code base to look very similar, and so that it like reduces the cognitive load when you're like doing PRs and stuff like that. And in the Python like world, we don't have to worry about this quite as much because, like as everyone knows, it's white space delimited. So we don't have to worry about like to have that conversation of like where do we put curly braces or any like that little stuff. We have like our own arguments. We don't have to worry about the curly brace argument. We deal with like the hanging like parentheses or something like that is kind of equivalent. But yeah, so consistency. And then going on with consistency, it also makes for faster code reviews. So at Octopus, we have like hundreds of developers and we're working really, really fast. So we want to be able to like review code as quickly as possible and not have all those conversations about like, oh, actually you should like put a blank line here, or you should do all this like other like little like knick-knack stuff that doesn't really matter as much. So we can like strip away as many of those things as possible, and so the code reviews are really focused more on like the actual functionality and the changes that are being made, as opposed to like little like things. And finally, linters are really great because criticism, I find, at least, I don't know about everyone else, but criticism from a computer is much easier to take than from another person. So if I push a bunch of code and Circle CI or whatever CI system you're using complains at you, that's much easier than like your boss coming over to your desk and complaining at you about that code. At least for me, I feel like it's easier. So we can codify a lot of these best practices and let the linter complain or let the build break. It turns out like to get developers to code in practices that you want, if you fail the build, like they actually start to follow those practices way more than if you have to code at their desk all the time. But you might ask, okay, those are all pretty good reasons, but like really, really why? For us, it's because of this. Like I said, we have 300 plus developers all around the world, 9 different countries. And if you like played our game yesterday, you would know that we have about 2.1 million lines of code inside of Kraken. So it's a lot of people working on something all at the same time. So we can't just rely on just code reviews because someone comes on the team, we try to get them to do a PR like in their first week or something. They don't really know any of the conventions, and then like there's lots and lots of PRs merged every day. So we need to automate that practice. So just like a tiny bit of background, if you haven't been to our booth yet and you want to know a little bit more about Kraken, it is like a giant Django like monolith application, supports millions of customers worldwide. And then I think I need to update this because someone said it was 14, but I can't count to 14. I can only get to 9. So I'm not entirely sure whether I'm wrong or someone else told me wrong. But yeah, we're adding more and more countries all the time. And like I said, like 300 plus developers, all working in one repo. And then, yeah, like I mentioned before, it's all for, like, I updated this slide because it recently was, like, I think I did this talk a couple of months ago, and it was only, like, 1.5 million or something. It is 2.1 million as of yesterday when we ran this. So if you can imagine yourself, like, being a developer that has worked for maybe, like, 2 years at a company of, like, 5 people, and then you get thrown into Kraken, which is very much like the actual Kraken. It has all 8 tentacles. It is massive. Being able to work on a code base of, like, 2 million lines with 300 other developers is a pretty difficult position to be in. So this is what it can feel like sometimes when you first come to Kraken, when you start working on it. It can be pretty difficult. So Constantine sometimes has a fever, sometimes you get a bump in your head, or sometimes your brain is just completely on fire because it's just so much stuff to put in there. So the one thing I want to mention, because I know we're at a Python conference, so of course everyone knows, like, I'm going to talk about Python linters, but one thing to note if like this is your first time coming to the like linter world or hearing about them, this isn't just a Python concept. This exists in a bunch of other ecosystems as well. Into the non-Python portion of the talk. Okay, so here are some of the tools that we're going to talk about briefly. We're going to give you like a little overview of like how we use these different like linters and formatters and stuff in Kraken, and then I'll give you a little overview about like how we actually use them. So first up is Black. I know the creator is here earlier. I talked to him at the booth. And it is known as like the uncompromising code formatter. I think that name probably comes from when Black first came out. It had almost no configuration, basically on purpose. So if you've ever been at a company and you start a project and you have like 10 software developers, pretty much the first thing you do is you all get in a room and you complain about style and you just like argue and argue and argue with each other. And you spend a couple of days and then everyone's mildly unhappy, but you kind of settle on something. Well, so Black skips that step. I like to think that Black takes a lot of the configuration out. Everybody is still mildly unhappy, but then you don't have to have that argument. You just like start with Black's configuration and go for it. But I think Black is probably easier to understand if you see what it does. So this is probably way too much code for a single slide, but we'll go with it anyway. The code itself is not too important. So if you look at this, like maybe you write code that looks like this. I mean, this is valid Python. It does work. I do have this pointer thing, so this is pretty neat. Like, you know, this looks a little weird. Like, I probably wouldn't wrap the code like that. I probably wouldn't put a bunch of space, like outside parentheses and stuff, or quotes like that. But what you can do is you can throw this code into Black, and you end up with something that looks exactly like this. So notice we have like a lot of white space here to make everything a little easier to read. And everything is like wrapped nicely, and it's just, I don't know, it feels a little more comfortable to work in. And I always tell people on my team too, like sometimes people will write code like this, and I tell them like, you know, white space is basically free these days. Like let's just like let the code breathe a little bit so that you can read it and kind of break it up into a little more logical concepts or little chunks. So that's what Black does. You feed it something that looks like this, and it gives you something that looks like this. My personal favorite thing about black, or maybe my least favorite thing about black, I'm not sure, but is that I really hate typing like double quotes. To me, it's like an extra keystroke. It drives me insane. So when we first switched to, or when I first started using black, I was like, oh, it uses like double quotes. That's very annoying. But what I found is like I can just set autosave in my editor to throw it through black, and so I can write all the single quotes I want, and it turns out looking like this, and everybody's code looks the same. So what black gives you is a lot of like this consistency, and again, you get to avoid that whole argument about what does the style look like. Just like a couple of like interesting little things that we do in Kraken, since we have so much code, and black can be kind of intense to run. I think 99 might be the default in the black configuration now. I can't remember exactly, but that's something that we do extend. Also, like I was a pretty like hardcore supporter of like, I sit in Vim all day, so I'm a pretty hardcore supporter of like 79 column lengths. But once you start adding like static typing and stuff like that, type definitions, it's like really hard to do anything in 80 anymore. So 99 is kind of what we use. And then we exclude, like we have some front end stuff in the Kraken mono repo. We don't like auto format those because it's mostly like JavaScript code. We're not going to like spend the time black looking for Python files in there. And then we also don't auto format like our migration files. If you opened the file up and saved it and maybe had your editor set up that way, that would work. But we don't bother like auto formatting those as either because those are like auto generated code. So another couple like interesting things I find about black is like one of the ways we use it is like I mentioned before, I put an auto save on my editor and then it just auto formats the code. But we don't use that in like our CI pipeline or like in our pre-commit hooks or anything like that, which we'll talk about later. We use the -- check option. So all that means is it tells black like if it would have reformatted any code to complain and like return like failure to the shell. There's a couple of reasons that we do that. I think the most important probably is that like if you're running black in something like in a pre-commit hook, the diff that you see is the diff that actually gets committed. Now, if we weren't using the check option, then if we maybe ran black after that, you might end up getting something checked in that wasn't exactly what you see. And then the other real reason is so that like formatting the code is still like the developer's responsibility, but you can just set black up to autosave in your editor. Another thing that I haven't I don't know that any other formatter, there's like quite a few other formatters. I think there's even one called Blue that's like a fork of black with like a few configuration options tweaked. But something that like is very cool about black is like when I came across it, I was like, I'm gonna give it my code and then it's gonna change my code and then commit it. Like that's very weird. Like I spend a lot of time trying to make this code work and then something's just gonna change it for me. That seems kind of unsafe. So black actually runs by default, I think, with this -- safe option. And what that does is black actually looks at the AST, the abstract syntax tree, and then it reformats your code and looks at the AST again and makes sure that those are logically equivalent. So it's kind of guaranteeing, like if you run with a safe option, which again I think is the default, that it makes sure that it doesn't actually logically or like change your code semantically. It's only just like the way it looks. And I don't know if any other code formatters do that, and I think that's probably a very, very difficult thing to do. So I want to like point that out. So like using black in safe mode is a great way to go. If you want, like I think really the only big benefit if you turn this off is that black does auto format it quicker because it doesn't have to do this AST like comparison stuff. So that's black. So if you're like me, you type a bunch of single quotes, you hit, :W in your Vim editor or in your PyCharm or whatever you want, auto formats your code, and then you get double quotes and all this nicely formatted code, and then everybody's code in the file looks the same. So the next up is isort. So what isort's claim to fame is like, I think it's kind of clever. It's isort your imports so you don't have to. It's kind of like a nice little name. So what does isorts do? It's another formatter or kind of like a formatter for your code, but only deals with imports. So if you're working on a project that's as large as Kraken, it's pretty common to have like lots and lots of imports in a file. So it gets very difficult to navigate that group of imports, like if you want to try to find a particular import, or oftentimes like maybe you have duplicate imports and you don't notice them because the import section is so large, like you just add a new one. So what isort does is, again, kind of like black, it's very useful to see if you just kind of like see what it does. So like you throw in code like this, and then you get something out like this. So again, there's like a lot of code for a slide. The code is not super important, but one thing to like note is that like there's some blank lines in there. And like I said, white space is free. We should all use it more. So it's broken into little sections. So like the first section is the like built-in stuff. And then the second section is like the third-party stuff. And then the last section is like the stuff that's actually in Kraken. So this is going to make it a whole lot easier to navigate those imports. If like you want to add a new import, you're like, oh, I'm adding like a new import from the standard library. What I tend to do is just like add it at the bottom and then have isort do like autosave stuff when I save the editor, and it just moves everything around and does it for me. And then I think it also removes like duplicate imports. So I don't know about you, but like if I'm given code that looks like this, and I save it and it looks like this, I kind of feel like this. It's pretty great. Like I get pretty happy. I don't have to think too much about it. Another really good benefit is that everybody's imports are in the same order, so it's alphabetically sorting them as well. So like diffs, you don't really get diffs because someone moved an import, which is very annoying. And again, it contributes to like faster code reviews and stuff like that, because you're not having to look at a diff of like import lines just moving around. So a few of the configuration options that we use in isort. Isort is unlike black in that it has like tons and tons of configuration options, plenty of which that I don't even know or understand. But we turn some of these on if you're like interested. You can tell it what's like a known third party or what's a known first party, because it doesn't necessarily know about your imports other than like what's in the standard library and what isn't. So that way you can get those like breakups in the chunks. Yeah, and then we allow trailing commas and stuff like that. Similar, some of the options that we use, isort has the same kind of thing as like fail if it would have sorted your imports, except for it, like in black, it's -- check. Here it's check only. So what that does is you feed your code into isort, and if you do check only, it will fail and return failure on the command line to tell you that it would have sorted your imports or not. So same kind of thing as we'll see later, we put it in our pre-commit hooks, and then we can fail if like you didn't sort your imports. So again, it's another thing that like you put in your editor, you hit save, you really don't ever think about it again. So now we've got like our code mostly formatted and it's consistent. And then we've got our imports mostly, or all the way formatted and consistent. Like now we start to get into more like probably more traditional linters, not necessarily code formatters. So Flake 8, it's not quite as clever of what their like tagline is, but your tool for style guide enforcement. But I kind of think that this is like really selling Flake 8 a little bit short for just like style guide enforcement. It turns out Flake 8 can do like a whole lot more than that. Yeah, they kind of sell themselves short a little bit. But again, let's just see an example of what Flake 8 can do so that we can see and better understand what we're looking at. So again, this is like really tough to see, but here's a bunch of code, and normally if I would like, we're gonna do this in a smaller setting, I would ask someone to like yell out, but this code doesn't actually work. And the weird thing is like there's this if statement here that says like, okay, if you're on a weekday, do this. If you're on a weekend, do something else. So like basically this function runs sometimes, and then this function runs sometimes. So down deeper, like this function sometimes gets called and sometimes it doesn't. So often like, or everybody knows like, or potentially everybody knows in the room, but Python's interpreted, so you don't necessarily hit an error until you actually execute that line, which makes it very difficult to write really good code. That's why like a lot of the like old C developers like me, when they like lose their compiler and they move to like a language like Python, you're a little bit worried. Like you don't have types and you don't have a compiler. Like how am I supposed to actually code reliably? This is kind of the Python answer, or one of the answers to that. So again, maybe you've already seen it before, but this code doesn't run because of this. So instead of the word to-dos, I type to-do. Very easy to miss. We all have very complicated lives. What's going on? Like that's a very easy thing to miss. But if we throw that code through Flake 8, it has a whole bunch of like configuration and like default stuff to tell us about like maybe a typo in a variable name or all sorts of different things that are just built into Flake 8, which is pretty great. So that gives us like a little bit of like what I would call static analysis on the code. So it's not like a compiler that's complaining about types or something like that, but it's at least like a little bit better in trying to like catch like more obvious errors. And then just, you know, maybe your website will be down a little less. But wait, actually, like I said before, Flake 8 actually sells itself short, in my opinion, about the like just a style guide or a code formatter kind of thing. And then just like another cute thing, a Constantine to pause and just like wait for everybody to like soak it in. If you need to shed a tear because it's so cute, that's fine too. So what else can Flake 8 do? It's actually fully customizable using Python. So you might ask, like, what does that actually mean? Like, flake8 is written in Python. Like, what do you mean by customizable? It means that you can write your own flake8 linters or your own like plugins. I forget exactly what the terminology flake8 uses. But that means that, like, if we have a coding convention, like, for example, at Kraken, we have quite a few, we can code those into flake8, put them in linters, set up our setup config file and that sort of thing, and we can actually complain at the code if you do something. So here's one that I kind of like simplified from Kraken, actually. Since we mostly develop like a Django application, we don't allow you to ever like commit code with the print statement. Just because it's not super that useful, like it's not really all that useful. Like if you're shelling in and like looking at the logs of the web server, like you might be already in the weeds, right? So we're just gonna not allow you to do print statements. So it is kind of funny, like when you first start working at Octopus or Kraken, you might commit some code with a print statement, the build completely fails. Luckily, you can never merge to master like that, so you're usually the only one that sees it. But it's kind of funny to have a linter come back to you and say like, hey, I failed because you have a print statement. So that's kind of the idea. Like the talk is not quite long enough to go through like the details of how you actually make your own flake8 linters and stuff like that. If you're super interested in me, come and talk to the people at our booth. We write a lot of these, and like for various different reasons. But the main idea is that like in this scenario, we want to just disallow code to be committed with the print statement. So we would, implement this. The thing about flake8 is it gives you the AST, so that's how you can kind of tell, like the AST is like a breakdown, like an abstract syntax tree of the code, so it's kind of this like structure that you can navigate broken up into expressions and like comparison and like operators and stuff like that. So flake8 does all that parsing and then kind of just gives you the AST and then the files, like the file name and the lines and stuff. So we can just write some like simple regexes to say like, hey, this line actually had print. We could do more complicated stuff if we were using the actual AST. In this scenario, we're just doing like a string matching in the lines. So like flake8 allows you to do a whole lot of complicated stuff. This is like one of the more simple things. Like you could have written this with just like looking through every file and like writing this regex. So it's not like the best example of like flake8's complexity, but it's an easy one to kind of grasp and get the idea. So yeah. And then also just like another little thing, we also don't allow the pretty print. Just another thing that doesn't really make any sense in a web app usually. So I went through the code base, and just to give you like an idea of like stuff that we have in Kraken, we don't allow unit tests that use the database, so we have linters to disallow that sort of thing, because unit tests should be completely separate from that stuff. You shouldn't be talking to the database. That's like an integration or a functional test or some other category of tests. We also have conventions that all of our celery tasks need to be in a task.py file. Another pretty neat one is that like consistent naming of date time fields. So we have like hundreds and hundreds of models. So we always name things like start at or end at or start from, effective from or effective at and stuff like that. You have to have the underscore at and the underscore from. So when you open up a model that has all these like auditing fields on it or it has other stuff like that, they're all consistently named. So if you add a new model and it has a date time field and it doesn't like work with this restriction, then the build or like you will not be able to merge it. Another one that is like super, super useful, like we talk a lot about like code coverage in Python community and people are like, oh, my code is like 99% covered. Well, it doesn't really tell you all that much because like what if all your tests don't have assert statements? Probably all gonna pass. So you have a whole lot of coverage and absolutely no testing. So it's pretty easy to accidentally write it. This is again like speaking from experience. It's pretty easy to write a test and forget to add the assert statement. And you basically just wrote a test that always passes. So we have like linters that like detect whether or not you wrote a comparison and you say like, hey, by the way, I think that comparison should probably be an assertion. And then we do some like progressive type ending. So Kraken's such a large code base, been around for quite like 5 or 6 years. We are slowly adding typing to it. So we have like linters that say when you add a new function, you have to add a return type. So we do flake8 on just the diff of that file so that like when you open up a file and say it has like 1,000 lines in it, and we just added a new flake8 rule that says you need to have return types on all your functions, you don't have to be the person that goes through and like adds the return types to like 15 functions or something in there. Instead, we can just do like flake8 can take input from standard in and then put it back to standard out and stuff like that so that we can see that we only want to add like return types to the function that you actually added in this commit as opposed to like globally. So we have tons and tons of flake8 linters. Very, very cool. If you're super interested in that, like definitely come and talk to me afterwards. And then just in the interest of time, we'll keep moving forward. So MyPy is like a static type checker. MyPy is like a talk all on its own, but it's kind of like us trying in the Python community to get like a compiler and to have like type checking and stuff like that. So like some interesting things that we happen to have in our configuration is like doing like strict equality, so like is versus equals equals and stuff like that, or like finding unused like ignore statements. You can have those like, I think it's like pound no QA or something like that, depending on which one you're using. So like a lot of, these are like kind of minimal things that MyPy can do. What MyPy really can do is like find out that you're passing different types to different functions and they're not matching. Also, import linter is something that was actually developed by developer David Seddon at Octopus, and it allows you to define and enforce rules for your imports, which means like we have a very layered architecture in Kraken, so we don't want like a bunch of circular imports. So like our dependencies kind of flow down, and you can define these layers in import linter with like a config file saying like this layer should never import this other layer. So in a code base that big as Kraken, this can really get you out of like import hell very easily. Yeah, so I'd encourage you to check out import linter. How do we use it? So there's like local and then there's CI. Here's how we do all of our stuff. So locally, you can do it with Git hooks. These are built into Git. They're easy to create and install, and they have lots of them. They're called like pre-commit, post-commit, post-merge, stuff like that. Warning though, when I say pre-commit, I mean like pre-commit in Git, not the pre-commit project. And people always ask me like, well, why don't you just use the pre-commit project? It's mostly because a lot of this stuff was added before the pre-commit project was like mature enough. So I don't have a great answer for that other than like time. So, okay, those are all the linters we have. Finally, like, Luke, get to the point. Like, how do we actually lint these things? So, like I said before, we can do it locally and on CI. So there's 2 steps to do it locally. We need to figure out what files to lint and then actually lint them. So a pre-commit hook in the Git terms is usually just like a shell script, or you can like call it whatever you want. In our case, it's usually just a bash script. So we do some like little bit Git magic to get us like a diff, and then get like the name, or like the name status, which gives you like an A, an M, or a D next to the file, and we pull that out. So now we know which files that we need to lint. So we know like we only want to lint files that were added or modified, not add files that were deleted. That's not super useful. So once we get the list of files to lint, we can throw them through all of our different linters with different configuration options that we have. We've already talked about before. So throw it through Flake 8, see if black is going to complain, then see if isort is going to complain. If it doesn't, great. You might notice that MyPy and import linter were not in that list. There's a good reason for that, because MyPy, Kraken is very, very large, and MyPy does a lot of very complicated stuff, so it takes a long time to run on Kraken. So as a pre-commit hook, when you make a commit and you're sitting there about ready to make a commit, we don't want you to have to sit there for minutes while MyPy tries to figure out what the types are. And similar thing for import linter, it's like looking at all your imports, so it's doing a lot of work. So both of these are just very slow to run as a pre-commit hook. You can run them outside of the pre-commit hook, and then they also run on CI. Downsides of Git hooks is people actually have to install them. You can usually symlink it in your environment, so it's not actually very hard to install, but that's one extra step. Also, Git includes this like escape hatch --no verify that just like skips the entire pre-commit hook. So if you're like one of those people that says like sets up an alias with no verify and you just do this all the time, not so great. So again, you want everybody to be using them. Like if you have all these linters and no one's using them, it's pretty useless. And then also to write Git hooks, usually you have to know bash, which is just like not a great time. If you're like me, you're like looking up how to do for loops all the time in bash, even though you've written bash for a very long time. So the best way to really enforce this stuff is to integrate it with CI. The main reasons is it's guaranteed to run, and then it also runs in a predictable environment with like all the same like configuration and all the same versions and stuff like that. So I think I have 1 more minute to go. Thanks everybody for coming. If you are interested, I think we'll wait and take questions at the booth. If you haven't, we are going to give away a big plushie Constantine if everyone hasn't seen that. So we're going to go and do that. But if you have any questions about all this like linting or have any ideas or any experience with it, definitely come and talk to me afterwards. And thanks everybody for coming.